Wing. We're live. Hello, internets.
Hello, internet.
Ooh, Rickles is here. Hi, Rickles.
Hi, Rickles.
Hello.
I need to turn off my own video here.
We should use my webcam next time.
You mean want to say here?
Yeah.
We can use it right now.
Yeah.
I mean, it's the same. That's what I want. I want to ask Dad if I could borrow his DSLR.
Your dad?
Yeah.
My dad doesn't have one.
I should get a DSLR so that I can blur my background.
Yeah, that would be so cool.
Oh my God, I'm sure you could do it with your MacBook.
Yeah, I could use.
It'd be pretty effective at it.
I could do it with software, but I want colors like you guys have. I like how you have such beautiful colors in your background.
Yeah, you can get Philips hues from anywhere. You can get them from Staples.
Mm-hmm.
Right?
Mm-hmm.
Costco.
Mm-hmm. There's a lot of things.
The website, the Philips Hue website.
Mm-hmm. Hey.
Yeah. Oh my God.
Look, you can do even with Discord. You can do background blurring. Ready?
Yeah.
It's not perfect, but it's. I mean, with the way Zoom kind of started that wave, they were like, all these other places wanted to create their own blurring.
Mm-hmm.
I don't like
it. Yeah. It's good to be able to hide your background, but the real deal has a, I don't know.
Once you know it's fake, it loses its appeal.
Or like making it more natural. More natural.
Whoa.
Ooh. You have some nice background going on there. I liked that city one, that animated city one. I don't know. I think the purple colors in the background are nice. Purples and blues.
Yeah. Look at those nice cool colors.
Anywho, should we start? Should we do things?
Yeah, let's do it.
All right. Let me drop the collaboration link into Discord. Okay. There it is. Join me.
This camera's too good now. It's too good.
It's not too good. But it is good. I like it. So, what are we doing today? What do we want to start with?
Like homework, you mean?
Yeah.
Okay. Well, we can start with mine. I was unsuccessful.
Okay.
In completing the converting left-hand letter program into a one-line regex format. Don't know acceptance sake for this.
No problem. Let's see what you did manage to do.
Okay. So the funny thing is about regexes is that the thing is I put so much brain power into making this regex, and I couldn't even get it to test. I mean, I got it to work in the regex regxr.com website in terms of finding the proper, like making sure it works for the words that I would like it to work for.
Yeah.
But having it implement into the code was something I was not able to do.
Okay.
Which, I mean, it's interesting. I can't get it. I don't think it works to test in a code format on the website. So,
right. Okay.
I'll show you what I have so far.
Let's put it. So we have a lefthand.js. Let's put it in there, at the bottom.
Okay. Okay, I'm joining.
Darkmon.
All right, so what I was trying to get at, that long-winded explanation, was that it will look like I did nothing.
Oh, don't worry. We're all having fun here. Today we're going to actually we're going to play a game, and I think the game will be fun.
All right.
Oh my gosh. So I was trying to look up stuff for the crossword with regex, only to find out that people actually make regex crosswords.
Uh-oh.
So I just kept finding regex crossword solvers. It's kind of insane, actually. They like, instead of horizontal and vertical, it's like hexagonal.
Uh-huh.
It's like a hexagonal crossword. So you're like going in all directions with like code.
Satch was getting so deep that she was getting close to pseudocode.
I know.
To like, or like pseudocode and what's it called? There was like self-writing code and like something.
I know.
Like
I just got to a place in the internet and I was like, where am I? This is too much.
Okay.
It's interesting.
All right, let's see what we got here. So you wrote is left letter, and then you have your regex here. All right, and you were trying to match one of... Okay, well, this is really good. This is a really good start. What's this stuff at the end here?
I was trying to get it to match, which is what we see down here. Like I was using this initially, and then it was telling me that this isn't a function. What I have selected there, and I was like, well, how do I make it work? And then so I found that this was an alternative way to get it to do something.
Okay, let's try it.
To get it to match, but using symbols instead of, or I guess regex instead of the actual match.
Okay, so here's how we would test this function. This is how you actually use it. You say is left. Well, I think actually there's a couple ways, but let's do it this way. You can say. So we know that segregated is a left-hand word, yeah. So we can do dot match on is left. You can use this, yeah.
Yeah.
So. And then we can do console.log this. Yeah?
Yeah.
Let's move this over actually to regex, because that bit of code there doesn't do much yet. So we can test more easily stuff out. All right, let's try it out. Node regex. So that's coming out null. And I believe it's actually coming out null because of this. You don't need the G. Let's try again.
Oh, how come we don't need the G? Because they don't need to scan it across the whole code? Is that why? Because it stands for global, which I know.
Right. Why don't you need the G? Yeah, that's a good question. I don't know. Don't worry about it. Let's just try it. Let's just try it at plain and simple first. Yeah. So this segregated is matching here, but you'll notice that what is matching is just the letter D. So the first part is what. Yeah, I see. So what let's try and break down what you actually wrote. So you put these parentheses, and what those parentheses did was it attempted to match this as a group. So let's move the parentheses over to here instead, so that we match this.
Everything.
Yeah.
Yeah? Okay.
And then let's see, accept read only. Baobabs is joining us.
Ooh.
Yeah, he's joining my editing session. That's cool.
Oh my gosh.
So he gets a cursor too. All right, so now when you do it this way, you can see that segregated matched, right?
Yeah. All right. I see.
Yeah. So now there's a little so you don't even actually need the parentheses. That's only if you want a capture group. So here it is matching segregated. Now there's a little problem.
And a capture group meaning like you want to be able to pull information out from the regex?
That is correct. So if you wanted to match, so let's say you had a long string and you wanted to match the whole string, but then you wanted to pull out a piece of that string, then you could use a capture group. In this case, we just want to match the whole string, right? So there's only one little bit of problem you have with this, which is, so this $ is an anchor. What it does is it ensures that you match to the end of the string. And then there's another anchor, which is the caret. And so if you add this caret here, then that is your actual regex that you want. So there's segregated matching here. Yeah? Yeah, so this pattern is now, we can call this the left-hand word pattern. So this is your whole pattern. And we can double check that this is working correctly by matching on, we can try to match on something that isn't a left-hand word. Like, for example, jump, which is a right-hand word. And then it comes back null. Yeah?
I see.
Yeah. All right.
Yeah, on the third line it comes up as null. Okay.
So that's the idea here. So this is basically how I typically would test a pattern in code. I would just put a bunch of console logs and try things out. Another thing we want to make sure is that if you do have a left-hand word that with like, I don't know, with like a right-hand letter in it, that it still matches, that it still doesn't match, right? Yeah.
Wow. Okay.
Yeah.
And okay. Nice.
Yeah. So let's head back to the left-hand problem and solve it using our pattern. So this is the left-hand word pattern. So I'm going to let you write the code here, and I'll just guide you through it. So right now we have this is left-hand letter, and we have this is left-hand word. Let's modify this code to use the pattern that we have now.
Okay.
I'm going to help you set this code up. So I'm just going to comment this stuff out. Oh, actually, before we do that, let's do a thing. Let's make sure, let's double check the code works, right? Node left-hand. Okay, sweater dresses. We established that sweater dresses was the longest left-hand word the first time we ran this code, yeah? Good. So let's just modify this code now with the new code that we have from the regex section.
Okay.
So, yeah.
All right, so let's get started here. All right. So it works. And so in terms of starting, we're like the way like I was thinking through it, was trying to break down like the first part, which was like the left-hand letter section. And the second part, like I was actually trying to convert each of those functions into regexes.
Ah, but you don't need to. You can do the whole thing in one function. You can do left-hand. So let's take a look at line 9. What is line 9 doing in the regex.js?
So it is looking to see if the word segregated matches the pattern regex, which is checking to see if these letters are inside this word.
or in more succinctly, I would say that this is checking to see if segregated is a left-hand word.
Mm-hmm.
So this is already doing all the work to know whether or not, well, this plus this line up here is doing all the work to tell you whether or not segregated is a left-hand word.
Mm-hmm.
And
Right.
you don't even need to check if there was a left-hand letter involved, because these two lines is sufficient to do all the work, right?
Yeah.
Yeah.
Agreed.
Yep. Hi, Mom.
Hello.
Hi, Mom.
And okay.
Yeah.
So I mean, the next part is. Oh, okay. So then I guess the next part would be like to build literally the longest word code or function.
Yeah. So let's do this. Grab lines 7 and 9, copy it, and then head over to left hand and just paste it at line 47. I'll drop a space for you.
Oops. 47. Here.
That was 49. 47 is right here. All right, cool. All right, let's analyze what we have. Yeah. So line 47 and 48, we have our pattern, our left-hand word pattern, and then line 48 will do one of two things. If segregated matches the left-hand word pattern, then it will print out this, like if you recall, it prints out the array, the matching array, yeah? Mm-hmm. And if it doesn't, it comes out null, right? So if the word segregated doesn't match the left-hand word pattern, then it would be null.
Right, which is equivalent to false or undefined.
Indeed. Yes, that is a pattern. Hey, Kent.
Kent is Baobabs.
Yeah.
Hey, Kent.
All right. So this is left-hand word function. The whole goal of it is to return true if word is a left-hand word and false otherwise, right? So we can do that with just lines 47 and 48 now, right?
Because it will, in the event where it is true, it'll return the word, but in the event of it not being true, it will return null.
Yeah. So let's do it. Right here, line 48. Let's check to see if word matches the left-hand word pattern.
So, I mean, console. Oh, will it be able to call for word if it's not inside the, oh no, wait, I see here.
Nice. Okay. So that does the console log. What we want to do now is actually, if it matches, return true. If it doesn't match, return false. So how can we convert that?
Can we... Will it work if we just try to run it like this?
We just need to put a return statement here. We want to say return. Okay. We don't end up needing the rest of this code, right? So what we want to do, if it matches, it's going to return not null, right? And if it doesn't match, then it's going to return null. right?
Okay. So yeah. So okay. So return. But I guess I have a question. So like in terms of if it returns null, well, correct me if I'm wrong. I was reading somewhere that a null is also equivalent to a false or undefined.
It is. It is. In JavaScript, you can do that. Do you want to do it that way? That I feel like that's fine. Yeah, that's fine. We can do it that way. So,
well, I also want to make sure I do like best practice type of thing. Like, I don't want to get into like a bad habit or something like that.
oh, don't worry about that. We'll worry about best practices after you're a confident programmer. Yeah.
Anytime now.
All right. Let's try the code out like this. Yeah.
Okay.
So there, it works, right? It's still printing sweater dresses. Yeah.
Nice.
So that's it. Yeah. That's all you had to do. And you can remove. You don't need this function anymore. We can get rid of that. Let's tidy up the code and see what it looks like after we've made. This is now your longest left-hand word code. One go here. So.
Insane, you guys.
Insane in the membrane.
Wait, is there a way to make it even more regexable?
Oh yeah. So do you want to? Do you want to see how tight we can actually make this code?
Well, I'm just like curious at this point.
All right.
I mean, I've seen some of the regex codes, and I'm like,
okay,
it's another language.
Let's do it. So, so I'm gonna make you do it though. I'm not gonna do it for you. I will guide you through the process of doing this. So here you've set a variable to left-hand words. You can make this code shorter by just saying word.match and passing the regex directly. So let's start by doing that. Go ahead. Okay, looks good. So we've reduced it by one more line. Let's try it again. Still works. Sweater dresses is still the longest word, right? We just keep testing every time. Next. So now you're calling this function is left-hand word, but you don't actually need to call, like if the function is just one line, you could just use this bit of code right here.
Oh, right. Yes.
So let's do that now.
Okay. Okay.
Okay.
So.
Yeah.
And then no. Can I? Oh wait, I can't do the terminal.
Oh, I can grant you. I think I can grant you access if you make a request for it. It will grant you access. But anyway, yeah. So there you go. That's as short as I think we can do. I mean, there's other ways to make it even shorter that have nothing to do with regex. Like for example, we can add. It's not important. I like this code to me is a nice way to write it. This looks good to me. So here we're clearly doing this thing. Now we did a bunch of work to make it nice and short, but the goal should not actually be to make things nice and short. The goal should be to make things nice and readable. Yeah? Mm-hmm. So you were asking me about best practices. At this point, you might say to yourself, okay, what are we doing here? Right? You might be tempted to go here and write a comment. Match left-hand words. Right?
Right.
But guess what? Before, when the previous version of our code, like we had a function that would do this. And it's clear what this is doing now without a comment, right? So at the cost of code that's slightly longer, we have code that's more readable. Yeah?
Right.
So my opinion on this is one of two things. This is how I would actually write the code. So you wrote it like this originally. What I would do is I'd take this expression, cut it out of here, and I would create a constant up here. Const left hand word pattern is equal to this. And then I would pass left hand word pattern here. This to me is readable. So I don't need to write I don't need to make an extra function call. But what I'm basically saying is if the word matches the left hand word pattern and the word length is greater than the longest word length, then store the longest word equal to the current word. Right? So this to me is nice and readable. But just putting this expression directly here, in my opinion, is not sufficiently descriptive to understand what it's doing. And so this is easier to read to me. You watched me do it, right? I was able to like read the code to you, and you were able to see how I was interpreting it, and that's an important quality to code. Hey, Niwako.
Hi, Niwako.
But did you talk about why readability is important? No, I didn't. Let's see if it's why is readability important? What do you guys think?
For your cohorts to understand, like if you're working in a group situation.
Yeah, your team.
Mm-hmm. Yeah, that's exactly right. That's the reason why. I would say actually that while we spend a lot of time writing code for the purposes of getting a computer to do what we want the computer to do, in many ways, there's actually many ways that we could write code to make a computer do something. But why do we have so many languages? Why do we have Python? Why do we have JavaScript? Why do we have like all of these different kinds of languages? And well, I mean, there's of course many reasons for all the different languages, but a lot of what we're trying to do when we write code, it's not just to tell the computer what to do. It's to work with others to build something. And because we're working with others, you could make the argument that programming is a social practice, right? It's the practice of writing code so that we can make a computer do something, but also so that we can communicate to other programmers how this code works. Where both of those are goals of writing code. And a reason why Python is so popular is because of how readable it is. JavaScript is popular not because it's readable, although it's gotten more readable over the years. The reason why JavaScript is popular is, of course, because it's the language of the web, and everybody uses the web. But if Python, if some other random language was the main language for a browser, that would have been the language instead. It just so happened to be, JavaScript just so happened to be the one that ultimately became the language of the web. Which is why it's such a great language to learn, and it's getting better. Like, they keep making the language better year after year. Like, they replaced var with let, so that let can be a better version of var, and then we just tell programmers, don't use the old thing, use the new thing, right? We improve it. Well, what's the point? Like, why are they doing that? What's the point of making these new things? One is, of course, to make it so that developers have a better experience. But the other is so that what we end up building is more readable to other programmers and is easier for other programmers to use. Because ultimately, a computer has no problem reading a variable one way or another, right? I mean, the computer will just do what it's told. It's not like the computer cares that we're improving the language. It's the humans that care that we're improving the language. Anyway, I will stop waxing philosophical. Good work. We're going to spend a bunch of time on regexes today. Also, sometimes even an experienced programmer like Shad forgets why he wrote the code he wrote a month later. 6 months later. So it's good to write readable code and add comments as necessary. Yeah, that's true. Yeah. I will.
That's a good point.
Mm-hmm. There are some languages that, for some reason, they really encourage you to write code that's unreadable after you finish writing it. Regex is one of them, just so you know.
Oh, regex.
That's the reason why we spend time giving the patterns good names. Because who's going to be able to read this? Seriously, what is this?
Don't you know Cortaz the Fugism?
Everyone knows that.
Okay. Next one. The next problem we were solving was... What was the other homework I gave you?
The crossword puzzle.
Oh, we'll get to that. What was the other? There was a third one.
Oh, was that the left-handogram? Was it that one?
Oh, yes. We were looking for the anagrams.
Longest set of anagrams?
We were looking for, yes, which set of words in the dictionary form the set of the largest number of anagrams. And I mentioned that was going to be a very, very hard problem to solve if you're a beginner especially. Did you work on it?
Oh yeah, we couldn't even get to that.
Couldn't get to that. Okay.
Part.
All right. Let's solve it on the stream together. Because it's a... Or do you want to give it a shot?
Well, what do you think, Satch?
We can give it a shot. Do you mean for our homework this week now?
I want to make more progress. It's okay. Let's solve it on the stream together. I have two fun things to do on the stream. One is to actually solve a crossword puzzle. This one here. I have this crossword puzzle that we could do together.
Oh.
We don't see it yet. Hold on.
It'll show up
there
on
it
the
is.
stream. Yeah.
But
So I feel
Let's do crossword.
can we actually solve it without code? I'm just kidding.
we could. Well, I think we'll need to solve it with some stuff. But I mean, the interesting aspect of this will be using code to cheat, and to see how we would build a program that would actually solve this. So yeah, we could. I think let's do both. Let's solve the puzzle while using code to help us. Yeah. So I got this crossword puzzle. I want to do that. But let's solve a problem together on the stream. So the problem is we want to find what words form the largest set of anagrams in the dictionary. And I think the ultimate goal is come up with the set of words, right? So is that going to be 5 in length? Is it going to be 10 in length? And what are the words? Let's say it ends up being 10. What are those words? Right? So let's think it through. How would you solve such a problem?
Well, I guess we would start with our recipe or pseudocode, right, as an opportunity to kind of break it down.
Yes. Yes, that's correct.
So pseudocode is not really the recipe thing. Pseudocode is a different thing.
Pseudocode is kind of the recipe. Yes, pseudocode is the recipe. Think of it as the recipe. So I'm going to just tidy up this file here. And then we'll be able to we'll solve it in here. So let's see here. Node anagram. False. Add an extra E. Okay, cool. So if you recall, so here's what we have already, right? We have the ability to check if two words are anagrams of one another, right? And the way we did it was by generating this thing called an anagram signature. Do you remember what the anagram signature was? Satch, you came up with it, actually.
I came up with it?
Yeah, it was you. You thought of it. Oh no, what was it? Or maybe it was actually Rickles.
It's like a fingerprint, but
Yes,
Mhm.
that's right. And if you recall, the way that we came up with it was we sorted the letters of the word, and then the sorted list of letters is the fingerprint for the word, is the anagram fingerprint for the word. So any two words that have the same fingerprint are anagrams of one another. Right? That's how we ended up with this bit of code. We were using the word fingerprint, not signature. Let's rename it. Anagram.
I think we're using
fingerprint.
both of them.
I like the word fingerprint. It's cool.
Mhm.
It's,
Yeah, it sounds cool.
it's cool.
Like we're hackers or something.
So, let's think it through. Yeah, how would you? Okay, let's start with the. So one of the problem solving skills that I wanted to let you guys know about was that solving a problem is like, okay, it's like a puzzle, right? You have a puzzle in front of you, and there's a number of ways you can solve a puzzle. You can search for pieces that look similar to one another and put them together. You can look at the box and you can be like, okay, let's do the frame first, right? And then you put the puzzle pieces down into the frame and then try to make them fit, right? So you can think of it as like there's a final destination, yeah? And this final destination that you're trying to get to is several steps that need to be taken before you get there. So you can either think about, okay, here's where we started, and where we started is a list of words, and where we want to get to is the fingerprint and list of words that match that fingerprint that is the longest in the dictionary, right? So those are the two. There's a starting point and an end point. Now the question is, you can be like, okay, we start with this dictionary. What's the next step? Or you can be like, okay, here's the end point where we have the fingerprint and the list and the longest list of words. What is the step right before that?
Can you repeat the question?
So remember, so the solution. Let's what is this? Let's talk about what the solution is. What do you think the solution? What does the solution look like? Right? If I asked you to find, if I asked you to go through the dictionary manually and just find like the list of words that's the longest set of words that are all anagrams of one another, what would you come back and give me?
We would give you essentially like just a list of all the anagrams that exist in the dictionary. Yeah.
With the longest ones highlighted? Or do you just mean a whole list of anagrams?
So I don't. Sorry, go on.
Well, so yeah, if you were asking for just like a list of the longest anagrams, then we would have like a bunch of different arrays that would hold all these long lists of. Oh, okay. I think I know what you mean. So, and we're not looking for the longest number of anagrams. We're looking for the longest anagram, the longest word that is an anagram. That's what we're looking for.
No, you had it right the first time.
Really?
Yeah. Because we already found the longest anagram. That was the longest left. We were able to do it. We were able to do an even more complex version where we found the longest left-hand anagram. So finding the longest anagram is just remove the filter on left hand, right? So that problem is solved. The first, what you're saying now is correct. Like we're looking for which set of words form the longest set of words that are all anagrams of one another in the English dictionary. That's what we're trying to get. Yeah?
Okay. Yeah.
So if I asked you to do that, if I asked you to solve this problem for me, and then you came back with the solution, how would you present me with the solution?
I would present a value, like a number. Like this is how many anagrams that can be created with this one set of letters.
Okay, that's a valid answer. So your answer to me is you would give me a number. Okay, you could also give me all of the words, right?
Mm-hmm.
You could also give me the fingerprint. So those are three valid options. Okay, so let's say we go with the you're going to give me the list of the words. All the list so in other words, you're gonna give me the set. In order to produce that list, what would be like? Let's say you could give someone else a problem to solve. That would be an intermediate step, and they would give you a solution. What would you ask someone else to give you so that you could get the list and give it to me? What would be the step right before that is basically what I'm asking.
Like we would have the list of words, the list of anagrams, and before giving it to you, we would give it to another person to refine the list?
No. Let me rephrase. So I come to you and I say, Satch, get me the longest list. Get me the list of words that forms the set of anagrams that are the most number of anagrams in the dictionary. And you're like, I don't know how to do that. So then you go to Rickles and you say to him, you don't ask him for the final solution because that's plagiarism.
Right.
You could just go to Rickles and just say, give me, like, ask for the exact same thing. But let's say instead you go to Rickles and ask for something else, right? Something that would allow you to give me my answer. What do you ask Rickles to give you? You can ask for anything. What do you ask? You can ask for anything except for the actual solution.
Except for the list of anagrams in the dictionary.
Right. You can ask for anything except that. But
it's still sifting through the dictionary word by word.
What's that?
In order to get the anagrams in this situation, we still have to go through the dictionary word by word.
Yeah, but you're still thinking about it from the start, right? I'm trying to demonstrate to you how you think about this problem starting from the end. So yes, you do need to start with just the words, and you do need to produce ultimately the longest list of anagrams, the longest list of words that are all anagrams of one another, and then give it to me. But you don't know what the middle step is. You don't know how to get there. I'm trying to show you how to solve this, like how to solve this problem by pointing out that there is a middle step, and that middle step enables everything. Yeah?
And this step is also a manual step.
Well, all the steps are, when you say manual, do you mean like a person has to do it?
Yeah.
No. Everything is programmable. I'm just pointing out that the steps are divisible into pieces, where at each step you produce a thing that's well defined, and then you can use that well defined step to produce the next step. Right? It's the same as how we did the left hand words, right? First step was check to see if the letter is a left hand letter. Be able to do that, right? Then the next step is check to see if the word is, if every letter in the word is also a left-hand letter. And that's how you know that something is a left-hand word, right? So let's go back to our story, yeah? You're starting with all the words. You have the ability to produce a fingerprint. You have the ability to check if two words are anagrams. That's actually not that helpful for this particular problem, but you have it. And the final goal is we're going to produce the longest list of words that are anagrams of one another in the dictionary. So I'm going to give you a hint, yeah? The step before the step before, like what you could ask Richard for is to give you, for every, you can ask Richard for a list of lists, right? Where each list is the set of words that are anagrams of one another. And just find the longest list in there.
Right.
So it's an array within an array.
Yeah, but we're not going to actually use an array inside of an array. We're going to use something else. That's another problem we're going to have to solve.
Or we need one of those two-dimensional things.
Let's talk about that. Let's talk about that now. Let's talk about that now. So Satch, if you ask Richard to produce for you this list of lists or something, right? That solves your problem, right? So so the next question is, how do you produce that? Do you know how to produce that?
The list of anagrams?
The list of anagrams, yes. So
oh my God.
So let me show you what that kind of looks like, yeah? So, or here's an even better way. Think of this as actually a phone book. I'm gonna give you the solution now, so that you guys can understand how we got here, right? We need to first produce, for every fingerprint that exists, all the words that can be that fall into that fingerprint, the anagram fingerprint, right? So, for example, we have this one here, which is EEHRT. Did I do that in the right order? I'm not good at sorting letters in my head.
Yeah, it is.
Okay, so that's the fingerprint. And then for that fingerprint, we want to associate it with every word that matches this fingerprint. So there and RETHE. And we can put this into, if you remember the types of objects that we have, we can put this into a telephone book. Remember the telephone book object? Right? So in JavaScript, this is called an object. But in other languages, it's called a map or a dictionary. I like the word dictionary because it's like you're looking up a key and a value.
Oh.
Right?
I'm trying to get my character map from before.
Yeah.
Yes, exactly. Exactly. It is exactly that. So if you asked Rickles to produce for you every single fingerprint with all the words associated with every fingerprint, and then he went off and did that and gave it back to you, you could then produce the set of words and the fingerprint with that is the longest
list.
You just search, you do the same thing that we did for when we're trying to find the longest left-hand word, right? You're just going to look through the lists and find the one that's longest, right? So that means that now, Rickles, you need to ask somebody to produce this for you. So
that's insane.
What's insane? Tell me, talk to me.
Like the amount of work that would be.
It's a computer,
also,
though.
How are you supposed to find the signature before the words? You know what I'm saying?
So let's talk through the algorithm now. Let's go through it, yeah? So let's start by step 1 is create this object, right? So let's create a dictionary mapping fingerprints, anagram fingerprints, to anagrams, to the anagram, to the words, essentially, right? Anagram words, okay? Initially, that dictionary is empty. It has nothing in it. So it's like you said, how do you start with nothing, of course. But then you do this next step where you look at each word. For each word in the well, let's not use the word dictionary because I use that for an actual dictionary of words. Let's call this create just a mapping of anagram fingerprints to anagram words. Okay, so this is the anagram fingerprint to anagram words, right? For each word in the dictionary, what are we going to do?
You're going to create a signature for them.
Correct. I'm going to get the signature for the word. Then what?
List out all the words that have the same signature.
Interesting. Okay. That's one way to do it. So that means there's a simpler way to do it, but that would work too. So if you look into the dictionary, compute the signature, right? You now have a signature, and you have the word. You have a word that matches that signature, right? So what you can do now is update your dictionary. Sorry, update your mapping. Update your phone book. You can say, for this signature, add this word to the set of valid anagrams. Right? Imagine you were doing this yourself, right? You'd be going through this thing. You would write it down on a piece of paper, right? You'd be like, okay, here's the fingerprint. Here's our fingerprint. Here's a word associated with that fingerprint. Then you look at the next one. You wouldn't actually go through the whole dictionary at that point to go and see other things that match that fingerprint. You would just move on to the next word because you have to process the whole dictionary anyway. So just go through each word one at a time, and for each one, compute its fingerprint. If the fingerprint is already in our phone book, right, then just add it to the existing fingerprint. Does that make sense?
Yeah.
So get the signature of the word. If the signature is not in the mapping, then add the signature. Add the signature to the map, right? To the phone book, right? When I say map, I'm talking about the phone book. Let me know if I ever do things that don't make sense. So if the signature is not in the mapping, add the signature to the map, right? And then once you've added the signature, add the word to the list associated with the signature in the map. Yeah?
Mm-hmm.
Yeah?
Yeah. Also, you're using signature again.
You're right. Fingerprint. Yes.
Whoa, cool.
Yeah, that I agree. Multiple cursors is one of the best things that's ever been invented. Let me get rid of these numbers. Okay. So this is what we're going to do. So, but this only does the step where we get the mapping, right? Once we have the mapping, we now need a new step, which is to run through this and find the longest one.
Yes.
Yes. So let's write that into our pseudocode. Yeah. So now for each fingerprint in the map, right? What are we going to do?
Make a counter?
Yes, exactly. That's right. So we need to start by hold on to the longest map of anagrams, right? Make it empty initially, right? For each fingerprint in the map, if the anagrams for that fingerprint is longer than what we're holding on to, then the existing one. Then we will update the longest one. And when we're done, we just print out the longest the longest map of anagrams. How does this look to you?
It looks good to me.
Looks good to you?
Nice.
Makes sense, right?
Mm-hmm.
Okay. Well, you'll have many opportunities to solve problems like this one. So I'm solving this one for you. Yeah? Should we start?
Let's start this.
Okay.
OMG.
Let's do it. So what we'll do is we'll just say let, let's call it the fingerprints is equal to a empty dictionary, right? So this is the create a mapping of fingerprints to anagram words, right? The initial one that is empty. And this is how you do an empty one. Okay?
Squiggly. All right, squiggly bracket.
Yeah, you remember this, right? Or no? This is the literal definition for a new object in JavaScript, also known as a phone book, as we've been calling it. Yeah, our phone book.
Yeah.
Okay.
Yeah, I remember the we changed objects.
So for what are we writing here?
Oh, God. Anagrams? Mapping.
So remember, this is what we're doing. Yeah,
Fingerprints.
this is what we're doing, right? We're going through each word.
Energize.
Do you want to type there,
Word.
Sach? Yeah.
Is
so,
the word?
yes. Let's go. Let. I'll
Oh,
help you.
okay.
Let.
Word of words.
Got it. Do it. Got it. Okay. Nice.
Don't expect more of that from you, though.
Oh, I can. I expect lots from you. Your problem solving skills are quite good, Sach. I'm impressed.
Oh my God. You're so nice to me. Thank you.
Yeah. Only because I have to be. My sister.
Yeah. You have to be.
And mom's watching.
Mom's watching you, okay? She knows what you're doing.
Okay. For let word of words. What's next? Sach, I think you can do it. What do you do? What are we doing next? Look, it's written right here on line 16. You just need to read our pseudocode now.
Get the fingerprint of the word.
How do you do that?
So, anagram fingerprint? Is
Yes.
that something?
Yes. That's how you do it. Okay.
Open bracket word?
Yes.
It seems the natural thing to do.
Yes. Good. It should be natural. These are called parentheses, by the way.
Yes.
I don't know why. Okay, so this is the fingerprint. So I will do const fingerprint equals this. Okay.
Okay.
The next thing is we need to check if fingerprint is not in the mapping.
Oh, is there going to be an if statement happening?
There probably will be, but believe it or not, I don't know how to check to see if an object contains a thing. So we need to write some code that does that. And the best way to do that is to look it up using the internets.
Oh yeah, internet.
So let's do a quick search, Google search for JavaScript check if object has key. This is what we want. If you're watching the stream, you can see. How do I check if an object has a key in JavaScript? And then scroll down to the answer that has 2,794. Wow. And the answer is this. You can say if the key is in the object. Do you see it on the stream?
Yeah.
Okay, I'm going to copy paste this code here for you. Be careful, the in operator matches all object keys, including those in the object's prototype chain. Ooh. Aha. So maybe we should follow. Yikes! This is one of the things about JavaScript. Because it's a language that because this language has gone through a lot of iterations. Sometimes the most obvious thing is not the right thing. I think that this is fine though. If it does cause a bug, for the interest of being readable, I don't care. If it's buggy, it's buggy. Who cares? Okay, here's the code you're gonna need. Okay, I'm bringing you back on the stream.
Oh my gosh.
Okay, Satch, you again. Yes? So this is how you check to see if an object, if something is in an object. So what we want to do is check to see if something is not in an object. And interestingly enough, actually, there is a better version from the Stack Overflow article. Let me put that one. So this is how you check if something is not in an object. Okay? So let's check. We want to check to see what? Hint on line 16.
Check if the fingerprint is in the mapping or not.
Correct. And if it's not, we need to add the fingerprint to the map.
To the map.
Okay, so do it.
Okay.
Actually, no, I put you on the spot too much. Rickles, your turn. Go.
Sucker.
Okay, the fingerprint is not in the mapping. Add the fingerprint to the map. Okay.
There's this key in my object situation.
A key in my object. What is that key doing there?
This stream is supposed to be you leave that one alone. Write your own thing.
You get your own thing.
Hey, one of these is so bad. Okay. If I'm tempted to just copy it.
It might be best to do so.
So we're checking to see if fingerprint is not in
the object.
What's the object?
The map. The mapping.
So what's the mapping? What did we call the mapping?
The mapping is the
mapping is the fingerprints, plural.
The list. Oh, yeah. Okay. Plural, huh?
Oh, okay, hold on.
Let's see your brain go to work.
Is it something like this?
Why do you know those things?
Oh, no, wait, no. It's...
Is
it like that?
You need to literally write it exactly the way that this is written here.
So you were right the first time.
Oh, no. Okay, let me help you. Uh-huh. Okay, no, okay, I'm not going to help you. You got it. You got this.
Key in... So literally exactly that?
Fingerprint in fingerprints?
That's right, Satch.
Oh my god, I did it.
No quotes. No quotes.
Okay. Oh, wait. Close. Wait. If it's not...
Type in.
Oh my god, In's a thing?
Yes. And now type fingerprints. Okay. All right, good.
Sometimes it's crazy how simple it can be.
Yeah, it's
'Cause it can be like this, or it can just be like a bunch of symbols. What's that about?
Okay, so let's read what we wrote. If the fingerprint that we calculated is not in the fingerprints, then we need to add the fingerprint to the fingerprints.
Yes. Okay. Add.
Do you remember how to do that?
Okay, so for the...
Is it a let or a for?
map.
I'm going to show you. We have it in our tutorial. So if you scroll to, if you look at the stream, I'll highlight it for you. So here we have adding we have adding Rich to the phone book. Do you see it?
Yeah.
So what we want to add is we want to add the fingerprint to the phone book, and specifically the contents of that needs to be an empty array.
Do we have to write phone book?
No, you're going to use fingerprints. Fingerprints is your phone book. My phone book is phone book. Fingerprints of...
Fingerprint.
Yep.
Do you have to put quotes in it?
Nope. So quotes is, you use quotes when it's a string, right?
Yeah.
Okay, so actually what you want here, Rich, is this. Yeah? Because what we're doing, remember what we're building, yeah? Let's take a, we're building, we're essentially making a object of these fingerprint objects where the key is the fingerprint and the value is a list of all of the words that match that fingerprint.
Okay, so yeah, all right. So you're creating a new object a new list within the object.
Yeah, and I'm sorry that I'm always using the wrong words. I'm mixing them up with words from other languages. In JavaScript, we call this an array, but you can use the word list with me. I don't mind. Yeah.
So the fingerprint here, so the key, when it's inputted in this way, it'll take the fingerprint itself and it'll make that that will be the name for this specific list that's here.
Correct.
Okay. All right, I see.
All right, we're making good progress. We're almost done, actually. Oh, yeah. We'll see. Okay, next line. Add a line after line 30. Okay, so now we've finished up to line 17. The next one is add the word to the list associated with the fingerprint in the map. I will do this for you. But basically what you're doing is, well, actually you could, so here it is. I'm highlighting it on the stream. Fruits, I did fruits.push. So fruits was the array, and we're doing fruits.push, right? So you need to access, you need to first you first need to get the array, okay? And to get the array, this is how you reference it. Yeah?
Right.
So you would do it like this. So here's your array dot push. And what are we pushing?
Hold on.
We're pushing the word, the non-fingerprint
Correct.
version of the word.
The word itself.
Yeah.
So you want to type it? Go ahead, Satch. Word. Type word.
Word to bird.
Oh God. Please help me.
Okay. All right, so this is it. This is the first half of the algorithm. Yeah? Let's test it, okay? It's always good to test things out. So here's what we're going to do. We're going to console.log, and we're going to console.log some random fingerprint to see all the anagrams of a given word. Sound good?
Oh yeah, awesome.
So here's how you do it. You say console log, and we're going to access all the fingerprints. And the fingerprint that we're going to access, right, is the anagram fingerprint of, tell me what word you want to see.
New letters?
No, a word. Give me a word.
Oh. Crap. Hand.
Let's see if Sachi has any anagrams.
Oh yeah, that's way better.
Uh-oh, we got some broken stuff. And
My name broke it.
it's okay, no.
We have to add the dictionary. Is it there?
I'll do it. Don't worry. Got this.
Oh, now I'll see how you do this.
Okay, try again.
You just copy and pasted it.
Oh, look at that.
Shays.
You're an anagram with Shez.
Oh, that's so cool. I never even noticed that when I use the word shays.
Oh, Satch, you need a Shays.
Satch in the shays.
You know shays is an English word too?
I didn't know.
It's a
I
piece
see it
of
now,
furniture.
Yeah, isn't that exactly what a chaise is? It's a chair, right?
Yeah, that's French for chair.
But it's not just any chair. In English, it's like
A French chair.
You jerk. Basically. God.
Okay. So we now know that we can be sure that this fingerprint object now has that massive thing that you thought was going to be such a tedious thing to calculate, right, Satch?
I did.
Yeah. It's all here now, right? This fingerprints, just for a moment, just ponder, like, it's huge. It's a huge object right now. It has every word in the dictionary, and it has a fingerprint associated with a list for all those words. And you can access it at any time, just like this. It's kind of mind-blowing, no? Like, you can just access anything you want. Like, you this is Satch, but you could just as easily say, let's get Rickles, you know? Does spelt Rickles wrong. Let's give it a run. Oh, look at that. Liquors and Slickers is Rickles is right? Let's try Baobabs, right? Baobabs. Let's see how Baobabs is doing. Unfortunately, Baobabs is the only word associated with.
The only bab.
Yeah, you can't anagram Baobabs.
What about volcano?
What about mom?
I'm gonna do volcano. Volcano is a unique word. No other word uses those letters. This is cool, right?
Can you do two words like Tom Riddle? Oh no, like Voldemort.
I don't think Tom Marvolo Riddle is in the dictionary as a single word.
It should be.
Darn it.
Sorry. All right, let's finish this. Stream's almost done. We didn't get to do the crossword. We'll do that next time. Sound good?
You can help me complete. You can help me with what I did so far.
I will show you. Sure. Yeah, let's do that after. Okay. So now we have this. We now need to do this part here, which is to loop over. First, hold on to the longest one, and then loop over the fingerprints, and find the list associated with that fingerprint that is the longest of all. Right? So let's go. Let's call this longest set of anagrams. Yeah?
Mm-hmm.
And the initial value will be an empty one. Okay? So this one should be the shortest. There should always be one longer than this one. Sound good? So what we now need to do is loop over all of the entries in the phone book, our fingerprints phone book, right? How do we do that? We ask the Google, loop through
Google Docs.
So here it is, loop through keys in object JavaScript. That's what we want. Object.entries. Here we go. Ooh, and actually, we have a nice... Okay, this will do. I'm going to copy paste it for you, yeah? Put it in a little comment for you.
Yeah. It has those anchors.
Anchors?
Are those dollar signs?
Oh, yeah, ignore that. That's just a console log. Okay. Satch, you want to try this?
Yeah.
I'll help. Okay, for loop.
Does it have to go inside here?
Nope. Okay.
And a const?
Parents, yeah, const. And so what is the key and the value that we're pulling out?
The key
What's the key?
is. Oh man, we went through this already. The key is the fingerprint.
Yes. So square brackets, fingerprint. Okay.
And then the value is the word. No. Is it fingerprints with an S?
Nope, you got it right. So the value is, remember, it's the list. It's the full list of words that match that fingerprint. So you can call it, we can't call it words because we use the word words for our dictionary of words. So we need a different word. Need a different word for word. Let's go with, you can come up with it if you want.
Oh no, no, you come up with it.
You want me to come up with it? This is okay. Naming variables is hard. It's one of the hardest things. I would go with maybe, let's call it anagrams, because these are all the anagrams. Yeah, sounds good. Small a. Gotta stick to this thing. Okay, and continue. We're doing this piece now. Yeah.
Can I just write the same words?
Almost. Of object. I'll tell you what to do. Of object dot entries. Yep. Parens. Parens is parentheses because it's just a very long word, so we abbreviate that to parens. Yeah. Parens. And what goes into those parens is the object that you want to pull the keys and values from, which in our case is fingerprints. Nice. So let's so good job, by the way, coming up with following along. I'm impressed. All right. So this is really great, right? Because we have the fingerprint and we have the anagrams, right? So now what we can do is we can just compare. We can say, we know that this is a list. We know that this is a list. If this one here is longer than this one here, then we want to store this here.
Right.
Okay.
An if statement.
You got it. If.
Nice.
Parens. I'm going to test you on parens. Okay. If. Anagrams. Dot. I believe it's length. I'm going to double check.
It totally is dot length.
Is it? Okay. I believe you then. Let's go with that.
Oh no, don't believe me just in case.
No. If it breaks, it breaks. We'll run it and then we'll debug it. Okay. If the anagrams dot length is bigger than. That's right. The longest set of anagrams is length. Yep. And now braces. Oops. You need that outside the paren.
Oops.
Parens. Okay. And now if that's the case, then you want to set the longest set to
Longest set of anagrams.
If this one is bigger than this one, what do we want to do?
We want to replace it.
That's right. Do it. Oops, I lost my terminal.
How do I write that?
You write longest set of anagrams equals anagrams.
Longest. Oh, anagrams.
And that will set this to be equal to that. Right?
Great. Yeah.
Looks good. Looks good. Shall we see if it works?
Yeah, we'll see if the dot length works.
And so I just need to log the longest set of anagrams. Let's see what it is. I'm so curious. We're ready to run this bad boy. There it is.
Oh my gosh. Oh my
So,
gosh.
so it's a 5-letter word, and it is these are all the words that you can form. It's what is that? That's 12. Length is 12, yeah?
Whoa.
Apers, apres, asper. All of these words I don't know. Pairs,
Cares.
pairs,
Parse.
spear, spare, reaps, rapes. Oh, rapes. Praise. Yeah.
There. Wow. Amazing. Did you get that in Boggle?
Oh yeah. I
Yeah.
should
Yeah, it's Boggle Solver.
Yeah.
we should do a boggle solver. That would be quite fun to do, just so you know. We could make a boggle solver. So what do you think?
Well, I love it. That's insane.
Problem solving.
And
Okay. Looks good. All right. So,
Okay.
yeah, right? Maybe that's French. Maybe the dictionary just has French words in it.
Yeah, shades.
Okay. What's next? Okay. So you were working on some regexes.
Crossword.
Yeah.
Ooh. I did not get far on this.
Yeah, no worries.
I'm gonna be really over now.
I want to show you the strategy. So let's solve a bit of this, and then your homework will be to actually do a crossword and use the computer to help you. How's that?
Do this one with code.
Yeah. Well, any random crossword you can pick up, you can try and solve it. So you'll have to use your brain. There's a manual process of like coming up with this, but like let's go like for example, let's look at 7 down. Picture imperfection. Starts with a B, ends in an R. How would you figure out what this word is?
In code.
Well, there's so like we can use the computer to help us. Let's see all possible words start with a B, end with an R, and are 4 letters long. Yeah?
Yeah.
So the way we would do that is we would do words dot filter. You can also write a for loop, by the way. For loop would work fine here. But filters are nice because we can just filter with a predicate. So I'm going to show you one way to do this right now so that you get the idea of what we're going for. The regex is the part that matters, not all this filter stuff. Your homework will be to come up with your own version of this, yeah? So you don't need to use a filter. You can just use a for loop. So words.filter, and then the predicate here takes a word. And we need to see if this word matches the pattern that starts with a B and ends with an R, yeah? So we say word.match. And if you recall, we do our regexes with these slashes.
Yes.
And we anchor to the beginning, anchor to the end. And then inside here, we want to start with a B, a letter we don't know, another letter we don't know, and R.
Excuse me?
I know, right?
Do you want to see my regex? It's so different.
Well, that's okay. I'm getting hungry, so I don't want to see
Okay, let's
regexes.
Fine.
I'm just gonna show you stuff, and then homework time.
Okay.
So let's run this. Node crossword.
That's so easy. The hey?
Okay, so here are all the words. There's only, what is that, 10? There's only 10 of them. Of these set of words, which one would be picture imperfection?
Blur.
All right. BL.
I was wondering what that word was going to be. I couldn't think of it.
All right, let's do 8 down now. 8 down is pleads. What's pleads? All right, let's try it out. So that would be starts with a B, ends with an S. Run our program. Oh, wow, that's a lot.
Oh. Pleads.
Oh, I know what it is.
Oh my God, there's so many.
Yeah, it's in here though.
Oh, bids? Is it bids?
Mm-mm. When you plead with someone, what's another word for that?
Bags.
Bags.
Yeah.
Good one.
All right, so we got begs. Okay. Let's do 16 across. Advil target.
16 across.
So let's see what we got. We have, wow, this is a lot of letters.
What the heck?
Okay, so let's go, yeah? 1, 2, 3, 4, 5, 6, 7, UG. 1, 2, 3, 4, 5. So we're looking for words that are that long with the letters UG in it. Thanks, Kent. See ya.
Bye, Kent.
Ooh.
Centrifugation.
I doubt it's any of these.
Yeah, I don't think it's the.
It's a
I
good
don't think it's either.
it's a good chance that it's not a word in the dictionary. Like it might be the name of something. Yeah.
Right. Or it could be like a phrase or a saying or something.
Mm-hmm. All right, let's try 14 across instead. It doesn't make news when it bites a dog. 4 letters, LE in the middle. So .LE dot. Run it.
Wow, this has a lot. Wait. These look like way more. Oh no, I see. Alec. Is it Alec?
So,
Oh, it's flea.
hmm?
Flea.
Yeah.
Wait, I don't know how to spell flea. How do you spell flea?
FLEA.
Oh yeah, okay. Ooh. So what do you think so far about what we're doing here?
It's so much fun.
Yeah. Yeah,
I
we-
should do more crosswords. I'm having fun doing that.
yeah. But just so you know, the homework here is to practice your regexes, yeah? So not so have fun while while doing some regexes, yeah?
Yeah.
I see you copy pasting that, but remember to write your own version of the code, yeah?
But is it also in my own version of the regex too?
Mm-hmm.
Dang it.
Okay. So that was it for our problem solving, actually. Let me bring your faces back. So that was problem solving. We don't need to, I think that's enough. There's going to be a lot of opportunities to solve problems. It'd be nice to go back to doing things starting next week. So just have fun with the crossword. Solve a crossword, take a picture, show me in the Discord. That's the homework.
Oh, yeah. That's going to be fun.
Yeah. And what we'll do is I have some more interesting problems that we can solve later. Specifically, they're related to our poker game. A very interesting problem that we need to solve is classifying hands in poker. Like, is this a 2-pair? Is this a 3 of a kind? Is this a full house? Is this a royal flush? And for every possible pair, 2-pair, 3 of a kind, 4 of a kind, full house, there's going to be different ones that are worth more or less. And so to know whether or not someone has won a game, you need to be able to check if their hand is the highest of a set. Right? So like given 2 hands of 5 cards each, which one is worth more? Right? If you need to be able to do that in order to decide whether or not someone has won. Right? So I think it'll be a very interesting problem to solve, how to map a poker hand to a value that you can then compare with another poker hand, right? very similar to Big Two, right? And when you play Big Two, you're trying to decide who wins each hand, right? So you compare. And there's a step-by-step process that you follow to do that. So I think that it might be fun for us to solve that problem next.
Oh, yeah.
Like, we can write some functions that do the comparison. So play the crossword, and the other bit of homework that I think will be fun to do is come up with the recipe for deciding in poker, like which poker hand is worth more than another.
Okay.
And then next time we'll start getting back to building things, because this is basically it for Crash Course, right? I showed you how to use a bunch of useful things. Let's quickly go through it one last time. Yeah. In our Crash Course, we went through all of these useful things: print, comment, primitives, variables, arrays, objects, the operators, the conditionals, the loops, the functions. We touched on classes, and you saw me do some array processing a little bit. We have covered the regexes, and this is basically what you need. All other things are built on this, right? You've got the fundamentals now. And that last problem we solved together, the anagrams one, that combined a bunch of things, right? We did problem solving beginning to end, like how to work your way backwards, right? Come up with the recipe. But there's multiple things happening there. We were not just solving a problem. We were also using tools that we had at our disposal. Things like arrays and objects. And what I'm gonna say something that I think is very interesting. You can solve almost any problem with what you've got now, with the exception of a few small kinds of problems that there's a certain class of them that is really like Boggle is actually a good example of it. Solving a Boggle board, like finding every word possible on a Boggle board, does require one more technique I never taught you. But almost every other problem that you can think of is solvable using some loops, using some objects and arrays to hold intermediate states, and like putting things into objects, like and adding things to arrays, removing things from arrays. Because these things that we're doing, objects and arrays, it's basically something that, it's analogous to something that you're doing on paper, right? You can solve a problem if you can think, okay, I need to make a dictionary, a phone book, right? And then you associate something with something else. Or you take something and you put things into a set. Those two operations actually encompass the vast majority of things you're going to want to be able to solve problems with. So the exercise of doing the anagrams thing was to see how you combine recipes with data structures to solve problems. And the rest of problem solving is really basically this. More and more of this. More and more complex versions of this.
Mm-hmm.
Mm-hmm.
We have the tools.
You got the tools. You have all the tools. Okay.
Awesome.
Thanks, Dan.
Thanks, Hatch. Thanks, Rickles. Okay,
Thank
let's say
you.
bye to the internets.
Bye, internets.
Bye, internets.
Peace.